everyone, welcome back to my channel The Math Learning Lab with Ruby Gupta. Today we will walk through the basic terminology of geometry. Understanding of these terms will make problems easier in geometry. So grab a notebook, pause the video whenever needed, and let's get started. So these are the three undefined terms: point, lines, and plane. So literally they do not have any definition for them. So the point is just a dot and represented by capital letter. The line is infinitely many points that extensively going in both the directions. There are the various ways to write down the line, which is given in here: line M, line PQ. PQ, on the top of that there is an arrow pointing towards both the directions, which is representing that line is going in both the directions. Line QP or QP, the arrow is on the top of that. A plane is a flat surface made up of points and it's extensively going in both the directions that has no thickness. Generally, the name of a plane is represented by italics letter written in the corner of the plane or any three non-collinear points. Like mentioned here, the plane K, plane BCD, because these are the three non-collinear points, or you can write it down plane CDB, DCB in any order, whatever you like. Ray. Ray is a straight line that continues in one direction, denoted as the ray FG, where the first point is representing the starting point of the ray and the point G is representing in which direction it is going. Next definition is coming angles. Angle is a two ray, and angle is a combination of two rays that are meeting at a one common end point. That one common end point is known as a vertex. There are again the various ways to write down the angle: angle POR, angle O, or angle theta. Mind it, you cannot write it down angle RPO because these two rays are meeting at an point O, not at point P. Opposite rays. Opposite rays are two collinear rays who have exactly one common endpoint and they are going in opposite directions. For example, here ray BA and ray BC, they have only one common endpoint. Angle bisector or trisector. Angle bisector is a ray or segment that divides a given angle into two or three parts, whatever it's needed. Equiangular. As the name implies, equiangular is a polygon in which all the angles are equal to each other. Just thinking, do you know any polygon which is equiangular? Yes, you got it right. It is an equilateral triangle. In the equilateral triangle, all the angles are 60 degrees. Congruent segments or angles. Congruent segments or angles are the segment or angles with the same measurement. Congruency is represented by the given symbol on the screen, equal to sign and the hyphen on the top of that. Perpendicularity. The next definition is perpendicularity. Two lines meeting at a right angle is called perpendicular on each other, and that point is called perpendicularity. There is a symbol is given here. I'm highlighting it. Segment D is perpendicular to EF. Line segment. A segment is a part of a line which contains two endpoints. Mind it. Again, we should have a two endpoints. If any of the one endpoint is missing, we cannot say it is a segment. That considered to be none of the geometric figure. Linear pair. Two angles are said to form a linear pair if they are adjacent and supplementary. Now you must be wondering what is adjacent. That you will be learning later. But for a brief intro, adjacent are the angles which are sharing a common vertex and the terminal ray. Or you can say in layman language, they are next to each other. Acute angle. Acute angle is an angle whose measurement is less than 90 degree and greater than 0, obviously, because you cannot have degree less than 0. Right angle is an angle whose measurement is 90 degree. In general, in the high school, when you're talking about right angle, there is a small square is given or the information is given to you. In general, you cannot assume any given angle is right angle based on their looks. Obtuse angle. Obtuse angle is an angle whose angle whose angle measurement is greater than 90 degree. Straight angle. A straight angle is an angle whose measurement is 180 degree. Vertical Vertical angles. When two lines intersect, angles across each other are known as a vertical angle and they are congruent to each other, meaning thereby they are equal to each other. For example, in the given diagram, angle 2 is congruent to angle 4, they are across each other, and angle 1 is congruent to angle 3, they are across each other, and they are equal to each other as well. There is a no relation between angle 1 and angle 2, but supplementary. Same as angle 1 and angle 4, they are supplementary. Same as angle 3 and angle 4. Adjacent angle. I already described in a brief when two angles are sharing one terminal and common vertex. This is a formal definition of adjacent angle. Complementary angles. When two angles added up to 90 degree, we say these angles are complementary. For example, in the given diagram, angle ABD is equal to angle ABC and angle CBD. They two are equal to 90 degree. Supplementary angles are angle whose sum is 180 degree. So angle measurement of angle JKL and measurement of angle LKM is equal to 180 degree. Parallel lines are the coplanar lines that do not intersect. In elementary grades, we have learned the parallel lines are lines which never meet. They keeps on going. But in the high school, we need to introduce another term, coplanar. Coplanar means they lies on the same plane. Transversal. A line intersected through the two lines. Lines may be parallel or not. For example, these two lines M and N are the two lines and line T is a transversal. Corresponding angles. Two angles are in the same place with respect to the transversal but on a different line and they are congruent. For example, angle 6 and angle 8 are corresponding angle, angle 2 and angle 4 are corresponding angle 5 and angle 7. Just wondering, what do you think about angle 1 and angle 3? Answer me in the comments below. Alternate interior angles. As the name represents, alternate, that means they has to be on the different side of the transversal. Interior meaning they has to be into the interior region of the parallel line. So the angles which are on the alternate side of the transversal and in the interior region of the parallel line. For example, in here, angle 2 and angle 7 are alternate interior angle and they are congruent. Angle 6 and angle 3, they are alternate interior angle and they are congruent to each other. Alternate exterior angle is another terminology related to the parallel lines. As its name implies again, they are on the different side of the transversal and they are on the exterior region of the parallel line. So in the given diagram, one is congruent to 8, they are on the different side of the alternate and they are alternate side of the transversal and they are on the exterior region. 5 and 4 is also alternate exterior angle, they are congruent to each other. Another terminology includes same side interior angle or you can say consecutive interior angle. Same side interior angle means, as its name implies, they has to be into the interior region of the parallel line and they are on the same side. For example, in this given diagram, angle 6 and angle 7 sum up should be 180, same as angle 2 and angle 3. Another question for you, just pause the video and think about what should be happen for angle 5 and angle 8. What should be their sum? And same as angle 1 and angle 4. Triangle. Union of a three line segment is known as a triangle. Now we will learn about the types of the triangle. Equilateral triangle in which all the side lines are equal. Earlier we have learned in this video what are the equiangular polygons. So equilateral are equiangular and equiangular are equilateral. Isosceles triangle, a triangle in which two side lines are same, which is known as a leg, and the third side length is known as a base. Right triangle, a triangle whose only one angle is exactly 90 degree. Scalene triangle is a triangle in which no side length is same. Space is a set of all the points. Distance formula. Distance between the 2 points x1, y1 and x2, y2 can be given by this formula that we are doing since our 8th grade. So we can easily do either using Pythagorean theorem or using the coordinate rule. Midpoint. A point that divides a segment into two equal parts. B is a midpoint of AB. Let's say the endpoints coordinates are x1, y1, x2, y2. Then coordinates of the midpoint B is given by the formula x1 plus x2 by 2, comma, y1 plus y2 by 2. Or you can say average of the x coordinates, comma, average of the y coordinates. Collinear points. As we all know, collinear points are the points that do lie on the same line. Segment bisector, any segment line or plane that intersects a segment at its midpoint. So in the given diagram, as you can see, CD is a segment bisector of AB. Mind it, AB is not a segment bisector, just CD. Skew lines. Skew lines are that are non-coplanar. They are neither parallel nor intersect. Before moving on to the practice sets, how about you get to know your math instructor? My name is Ruby Gupta and I currently am a math instructor in USA with more than 9,000 hours of teaching experience. I have cleared my MPhil for secondary mathematics in USA. Now that you have gotten to know a little bit about me, let's move on to the practice sets. So use the diagram to answer the following questions. How many points appear in the figure? As we already discussed, the points are clearly given as a dot. So you can count as a point Y, point X, point W, point V, and point Z. So total 5 points. How many lines appear in the figure? Line A and line B. There are the various ways to write down those lines. You can write it down line VX, line VW, line YZ, line WZ, and so on. How many planes appear in the figure? As given, it's only the one plane. Later on, we will learn there are the different conditions to determine a given plane. Name a line containing a point V. As you can see, the point V is as a dot on the line A. So it is a line A to the answer question D. Name the intersection of a lines A and B. So where these two lines are intersecting, they're intersecting at point W. Give another name for line B. So there are the different ways to write down the line. You can write it down line YW, WZ, YZ, and ZY, ZW, so on. Name three non-collinear points, the points that do not lie on the same line. YWX, YWV, YVZ. So many points you can write it down. Another problem. Determine the measure of each angle indicated by a circled letter. For example, if we need to work on the circle letter G, only the thing is we know angle 65, angle G, and angle 75, they're supplementary. So you can add these two angles 65 and 75, subtract out of 180, you will have a letter G. Same way you can work on angle 55, angle 50, and angle R as well, and so on. For rest of the answers, you can comment your answer in the section below. Using the diagram, classify each triangle by its angle. For example, triangle CDE. So draw the line on the segments CDE. You see here is a small square is given. If the small square is given, then we can consider it as a right triangle. So triangle CED is a right triangle. Triangle BCE. Triangle BCE. We see here the one angle is an obtuse angle. So we will consider this triangle as an obtuse triangle. You can practice further for these problems. Take a pause, draw the diagram, and work on these examples. Next problem. How many line segments are in the below image? Name all the line segments. You can see segment PRTS. I'm wondering why not we can write it down PQ. Well, you listen. Yes, we can write down PQ and QR, TQ and QS, PR and TS. So total 6 line segments we see. There is another problem to try on based on the angle bisector and the congruent angles. In the given diagram, angle MQN is the same as angle NQO, or you can say they are congruent because they have a same symbol here. Angle LQM, angle OQP, they are also congruent to each other because they have a same symbol. Now, based on the given information, label the diagram and calculate rest of the given angles. Another one. Name the vertex of the angle. As we discussed already, the two rays meeting at a common point is known as the vertex of a given angle. Here the ray KL and the KJ is meeting at a one common endpoint, which is known as a K. So vertex is a K. Name the sides of the angle KL and KJ. Give three ways to name the angle. Remember, I told you K has to be in the middle because it's a vertex. So you can write it down. Angle K is a one way. Another way is angle JKL or LKJ. Classify the angle. It appears to be greater than 90. So you can consider it as an obtuse angle. When you're talking about the high school geometry, for the right angle, the information has to be given. But based on the appearance, you can talk about it's acute or obtuse. Here is another problem to try on based on the congruence, different ways to write down the angles, classification of a given angle, two congruent angles, and which two sidelines are perpendicular or not. This is a very common problem too, where you have to draw the diagram based on the given description. For the given diagram, you have to draw angle ADC is a straight angle, so draw the straight angle, straight line. Angle ADC is a right angle, so draw another right angle that contains the AD part of it and draw angle BD is an acute angle. If you have difficulty with this question, let me know in the comments. I will just post the answer to it. Name the vertex of each angle. For example, 1, angle 4. Angle 4 is at the vertex T. So vertex for angle 4 is angle T. Question number 2, vertex for angle 1. Vertex for angle 1, it is a W. So it is. Answer is W. Name the sides of the each angle. For example, angle 4. What are the two sides consist of the angle 4? So which is UT and ST. For example, angle STV. So draw the line over STV. So you will see the ray ST and TV. Write another name for each angle. For angle 3, I can write it down angle WTV. Just wondering, can I write it down only angle T? Or it should be WTU or it should be STU. Let me know your answer in comments. For angle WTS, question number 11. WTS. So another name for this angle would be just the angle phi. Or STW is another name for this angle. For rest of the them is a practice problem for you to try on. Based on the given diagram, you have to evaluate the rest of the angle. If the information is not given, you can write it down not enough information. As we already discussed, for the given diagram, although it appears to be the right angle, but you cannot consider it's a right angle until it's given or the small square. So for angle 9 and 10, it appears to be right angle, but we cannot assume. So angle 9, we cannot calculate, even though we have angle 10 is 50 degree. Same as for the angle 11. Only the information we have angle 10, 11 and 9 added up to 180 and angle 12 and angle 13 added up to 180. We do not have any other information and we cannot even deduce any of it. So for this question, you can write down not enough information. Here is another algebraic problem to try on based on the collinear points. Another one, write the name of each diagram in as many as ways as possible. As we discussed in the first slide, this is a line. So you can write down line RT, line TR, line M, or another ways. Point, sorry, B is a segment PQ, or you can write down QP as well. Answer to question C is a ray. You can write it down CD, DE. Just wondering, can you write down the ray CE as well? Let me know your answer. Thanks for watching. Feel free to post your questions in the comment section. Please like, comment, subscribe, and share.